So listen up, and then followed by live Q&A. We'll be back with Esteban live soon.
Hi, my name is Esteban Serna. I am a principal DynamoDB Specialist Solution Architect. And in my role, I help customers working with Amazon DynamoDB. I make anything that is needed to make them succeed with DynamoDB. I help them with data modeling, with cost optimization, application design. In reality, I help them with any question they might have about DynamoDB. Today, we are going to be talking about the Database Modernizer workshop. And in this video, I'm going to give you the 3 main pillars you need to base your application modernization. I have been working at AWS for the last 6 years and with NoSQL databases since 2010. Application modernization, it is a complex subject, and it requires the involvement of all the stakeholders. We require application developers, we require solutions architects, database administrators, and business stakeholders. It is a great moment in the application lifecycle to decide about its future. Today, we will be talking about, first of all, how complex it is to modernize an application. We need to really understand all the process involved so you can appreciate this workshop better. I'm going to present the Database Modernizer workshop and the 3 modernization pillars that are very important in any application modernization. This will be followed by a solution overview. I'm going to give you an idea of what will be your setup to execute this workshop. And then we will go deep into the workshop itself and with a deep dive and a live demo. Now, we have to start at some point, and we need to understand the application modernization process. You usually start with a working application, which is in production, of course. Most of the cases, these applications are based in a SQL database behind the scenes, and you have some application logic that connects to the database and then executes some of your requirements, all of your different access patterns. Now, you have some SQL functions, depending on your SQL database behind the scenes. You have some application logic to connect to the specific database. In some cases, and I have to say there is a lot of times that I see customers writing what I call application logic in the database. So in the name of store procedures, in the name of triggers, on some other things that you abstract the application and put a portion of that logic in the database. Normally, when you have an application, it is stored in what we call third normal form or normalized views, where you create one table type for each one of your data types. A table for users, a table for products, etc., etc. In the modernization process, and in this case, we're going to be migrating to DynamoDB. Now, you still have your application. That will not change. What it will change in the middle, it is the database that you will be using. So instead of working with SQL, you will have to work with DynamoDB APIs, which is RESTful APIs, and you will be still handling your application logic through these different API calls to store your data in some DynamoDB tables. We don't know how many of these tables. It might be 1, it might be 3. You have to make that decision, which is really where the problem begins, where this modernization process becomes complex. At some point, since you have all of your application in the source database, you need to transform it somehow to move it into DynamoDB. So there has to happen a schema transformation. So you need to understand your access patterns, which hopefully you have them documented somewhere. And then based on your requirements and data velocity, so how hard you're going to be hitting your database, how many requests per second on read and writes, you will have to craft a DynamoDB data model. This will be followed by an application refactor. So you have created your schema and your new tables in DynamoDB, but we speak a different language. So we don't speak SQL, and you will need to modify your application so you can actually write and communicate with DynamoDB using the DynamoDB APIs. There are a lot of techniques that you can use here. We, based on customer feedback and development best practices, we suggest to apply a dual write approach or an abstraction layer where you keep your application logic isolated, but then you enable behind the scenes different access layers. One of the access layers, which will be the existing one, connects to the SQL database, and the other access layer will be the DynamoDB one, which will allow you to connect to DynamoDB. But seamlessly, you will connect to both applications, and you will have to define that later. We'll go deeper into this topic later. Finally, once you move your application and you finish coding, it is the time to move the data. You have all of your gigabytes or terabytes of data in your source database, and somehow that needs to be moved into DynamoDB, ideally with as little as possible downtime. You don't want to take off your application just to move the data from one side to the other. If we're talking about 10 megabytes of data, that might be very fast. But what if we're talking about terabytes of data? So that process really depends on how big your application is. And everything that I'm telling you absolutely depends on each specific use case. So there is no blanket statements that I'm going to be making here. I'm going to give you directions. And this is what we will be doing in the workshop, giving a lot of directions. Now, introducing the Database Modernizer, it is an AI-powered workflow that will accelerate your application modernization journey from what it will normally takes about 18 months. This is what we see customers taking the time to modernize their application, to some days by using automated analysis and human-guided decision points. It is very important, and I will maybe say this 100 times in this presentation. We need the human to make all of the important decisions. Gen AI can do a lot of amazing things and can identify patterns, and, well, it's really good at it. But the human needs to make the final decision. So this is not a one-click solution that will migrate everything for you. You still have a lot of work to do on the modernization process. And when we say that it's going to be a couple of days, that will be the best case scenario. Usually, you will spend more time analyzing and understanding all of the outputs of this workshop before you move between steps. Now, the three main pillars, and these are repeated across all modernization processes that I've seen with many, many customers. The first one, which is the most important, it is the data modeling pillar. You need to understand your application access patterns. If you're going to start a modernization journey and you have no idea how your application behaves, you really need to spend time collecting every single data movement, all of the access patterns, how your data actually behaves in your application. You need to spend as much time as possible here, because this is the base for everything else behind the scenes. What we will do in the workshop, we will connect to a MySQL database using the MySQL MCP server. We will analyze table structure. We will see what data you have in your database, and you can use that. You can just change. We have created the workshop to work with a MySQL database as an initial stage, and in the future, we will expand to more databases. But the approach is very similar to all databases. You really need to understand what you have in your database. As simple as that. In addition, you need to explore your application code. You will see all of the different APIs, if you have defined them by APIs, and all of the patterns that the application will need to support. At the end of this pillar, you will have a document, an artifact that contains your access patterns, the query velocity, and well, that's it. That's the main information we require. Also some sample data, because you will have to connect to your source database and understand how do your data looks like. Now you move to the second pillar, which is the one that is less related with databases in general, because you need to refactor your application. At this point, we recommend to implement this abstraction layer. So you connect to both databases at the same time, old database and new database, without impacting your application. This also will allow you to selectively control your application at different stages. If you enable connectivity to both databases at the same time, you can define when you read from both or when you can do a dual write. So you are comfortable while you move and migrate all of the data from one database to the other. This will take a lot of time because you really need to understand your application code. And depending on how the code was created before, then the refactoring will take a lot of time. In this workshop, we have a REST-based application that has isolated access patterns and database communication layer. So you can literally put the abstraction layer in the middle and can connect to both databases when you enable DynamoDB. We use test-driven development, and every time a new feature is added, we execute unit testing and integration testing and a bunch of unit tests that we have defined in the application, because given the undeterministic nature of LLMs, sometimes they hallucinate or sometimes they create functionality that you didn't ask for. The test will make sure that that doesn't happen, or at least is minimized as much as possible. In this stage, it takes a lot of time because of the unit testing execution. Once you create the abstraction layer, you will do the DynamoDB implementation, because you are adding the new APIs that you need to speak, the new language you need to speak to. And finally, you will enable the feature flags. One of the most, it is not very used, the feature flag functionality, especially during migrations. Feature flags will allow you to control how you move your data between different stages. By saying, for example, DynamoDB equals true or DynamoDB write equals true, you are saying, go and write to DynamoDB. If you implement those flags, you can control how your application moves your data. And this will be very handy in the next pillar. So at the end of this pillar, you will have an application that can speak the MySQL jargon, let's call it, and DynamoDB APIs. You will have feature flags enabled and an admin portal that will allow you to control the feature flags. The final pillar, it is the data movement. It is usually the most scary portion, because this is where you are actually sending the data to the new database. We recommend using dual write approach. I acknowledge that different applications might require different strategies, but in this scenario, we are trying to minimize downtime. So we will go with a dual write approach, where whenever we are ready, we enable the writes to both databases, and then behind the scenes, we move the data using an ETL process and the Glue MCP server, which is called the Data Processing MCP server. And then you can move the data to DynamoDB tables. regardless of what technology you're using, the three pillars remain the same. You need to understand your data. You need to modify whatever you had before in your application. And finally, you need to move your data to the new solution. It is very transparent in this approach. Now, the solution that I've built is very simple. And I was always thinking about how can I make sure that everyone can access this? So when you start the workshop, if you're using Workshop Studio, which is our environment where you can safely play around, all of this will be deployed for you. So you can just get and connect to the solution and start working on it. But if you're doing it on your own, you will be able to download the scripts because everything is in GitHub. It is a set of prompts that it will download and some tools. You will be using the MySQL MCP server to connect to the source database. You will be using the AWS DynamoDB MCP server for all the data modeling questions. And then we will be using the AWS Data Processing MCP server or the Glue MCP server to perform the ETL process. We will need to create a MySQL database and a backend server in the cloud just for simulation processes. You can also run that locally. And we will create some VPC connectivity to ensure that we can connect to Glue and DynamoDB from the EC2 instance that we have created. Now, in the workshop, we spent a lot of time making sure that we use the right prompts to analyze all of the steps that we have created. We really need to give the LLM a very narrow task. We all know how creative LLMs can get, so we really need to be sure that the task is very simple. So I have divided the prompt process in 3 different files. The first file is called the requirements, which tell us what needs to be built. The business goals and what are the user needs. It contains the acceptance criteria, all the problem context, and if we have any constraint and the success criteria. This is the only information that it has. It's very business related. The next file, it is called the design document, which will tell the LLM how it will be built. It contains the technical architecture, technologies that you will be using, all of the implementation details, and a decision rationale in case of there are some that it needs to make a decision. It contains what algorithm it will follow. Finally, we have the task file. Task tells the LLM what needs to be doing next. It is really a specific actionable coding task that will be executing. You will give them the exact sequence it needs to follow, and you will put the reference to the files and prompts that you will be using. It really contains concrete actions. And I've spent a lot of time modifying these files to make sure that we don't get a lot of rounds, because sometimes when you work with LLMs, it starts going in circles and keep going and repeating some of the stuff. The idea here it is to make sure that you are as efficient as possible during the modernization process, but I did include some retroalimentation, some questions about what you did. For example, if you create a data model, before finishing that stage, I ask questions about, are you sure this is what you need? Just a final safekeeping. The Database Modernizer workflow, it is based on prompts and tools available on GitHub. You can download that. I'm going to share the resource later. And we make sure that all of the prompts that we created in the workshop follow AWS best practices. And again, humans are needed for confirmation and supervision for every single step that you are doing during this process. Now, into detail. So each one of the pillars are divided into different stages. So I'm going to be telling you what each stage do, so you are prepared for the workshop. In the first stage, we analyze the source database. We connect to the MySQL MCP server. We identify the table structure. We understand what is built today in the database. We generate an analysis artifact, which consists of 3 files that we will be using later in the analysis. In the second stage, we will use the artifacts generated before, and we will feed the DynamoDB MCP server with that information and ask for a data model recommendation. You will be seeing something in this workflow. Each stage generates an artifact, and that artifact will be used in the next stage. It is always going forward. In the second stage, so you get the DynamoDB data model using the DynamoDB MCP server. Doesn't mean that you will be doing one execution of the data model. You can chat with your data model. You can contradict what this MCP server is telling you. So you can ask the LLM for options. So you don't have to accept everything that it's telling you. But we have spent a lot of time making sure that the DynamoDB MCP server gives proper advice for most of the use cases. In some cases, when you don't have enough information, the DynamoDB data model will give you a data model, which the information that you have. So make sure that you put all of the access patterns and data velocity in there. Once you finish the DynamoDB data model, we generate what is the most important file in this workflow. It is called the migration contract.json. This migration contract will serve as the directions on how you are going to migrate the data from source database to destination database. Let's say that if you have created a user table, a user properties also table, 2 different tables in the source database, maybe in the destination database, it will be all moved into the users table. So it will tell you how it will need to transform the user's data in MySQL to DynamoDB, and also the user's property data into the users table. So it contains all the transformation that you need to have. Then we move to the stage number 3, where we create the database abstraction layer using, again, the migration contract. If for some reason you make a mistake on this migration contract, you better catch it earlier before you go to all other stages. Because if not, you will have to repeat the migration contract and then go back and regenerate the code, which is a lot of work. Once you create the database abstraction layer, following the test-driven design logic that we said before, we get to the stage number 4, where we make sure that we can connect the DynamoDB tables and we can execute the different DynamoDB logic. And we go to the stage number 5, that is going to enable dual writes. Remember what I told you about the feature flags? This is what is implemented, and we will get an admin portal or an admin dashboard at the end that will allow you to control how you move your data across different stages. Finally, we get to the stage number 6, where we deploy the AWS infrastructure, DynamoDB tables, and with the Glue jobs that we will be used to move the data across. And finally, at the end of this stage, you will have DynamoDB tables and an infrastructure ready for the data movement. So you have to decide when you move from one side to the other, starting at stage number 7, when you migrate your data. And after you do all of this process, starting with dual writes, once you do dual writes, you enable reads from DynamoDB, but checking if the read is valid in MySQL, like making sure that you can always roll back. That's the beauty of this feature flags functionality. You always have a safe environment that you know the application is working. When you are comfortable that all of your data is successfully migrated, you can turn the switch to read data from DynamoDB, but validate if in MySQL is still okay. So remember, always in control. And finally, you just decide to do the migration and move everything to DynamoDB and remove the connection to the MySQL database. and your migration will be completed. So these are all of the steps in the workflow. We make sure that we have all of these steps ready for you so you can always roll back to a safe place. Now, let's have a look to the demo. This will be the shop store application that we will be using. It's our sample application. It is deployed. I'm using the workshop environment right here, right now. It is based on an EC2 instance. So this is the environment from the workshop studio where we will be using the sample application. It is called the shop store. It is an e-commerce application, contains all the normal functionality that you will have in an e-commerce website. So you have some products and you can browse by categories and you can select which category you want to buy your stuff. And let's say that if you want to buy this one, you can add items to the shopping cart. You can go and do your shopping cart and proceed to a checkout functionality. I'm going to select PayPal in this scenario. You complete your order, which will be auto-approved. Don't worry, this doesn't go to a real PayPal. And that's it. You can go and see all of your order history. It is a very normal e-commerce application with the different functionality that you will expect. This is the view of the workshop application where you will see all of the different steps. If you decide to run the workshop with us, you will start with this web page and it will tell you the different steps that you will have to follow over here one by one. I already pre-configured the environment for us so we can see the most important elements. So when you clone your application, you will have this view. A bunch of folders with a lot of files that are in there. Let's explore the prompts. So we have 7 different folders. And if I click in MySQL analysis, for example, and I click on the task, you will see that we really go detailed on what it needs to be doing. We even tell them how they need to send the Git commands, how they need to complete the tasks, and what they need to be doing initially. For example, go and create Git, make sure that you have a clean environment, and etc., etc. All of this information, it is already pre-completed for you, so you can focus on the interesting portion. Each stage creates artifacts. So I'm going to click on the stage number 1 folder over here, and you will see what I meant before to understand the application access patterns. So we connect to the source database and the source code and really list one by one all of the different access patterns we will need to be supporting. If I scroll all the way down, you will see that we have a list of 48 different access patterns that our sample e-commerce application needs to support. Here in the middle, we will have an idea of all of the different entities that we will be needing to support in the future. We also have a MySQL log analysis that tell us how quickly we are sending read and writes into this database. And then we have a table structure analysis. All of this information is used for the stage number 2, which I already started, and I'm going to show you that in a second. And we generate a summary document called access patterns with requests per second. And it tell us how many requests per second we are expecting, the load, and different access patterns, and an association of these numbers. All of this information is super important for the DynamoDB MCP server, so you can generate a right data model for you. So if I click, and then you will see that we have the list of all of the 48 access patterns. It is your responsibility to make sure that what you have in this file, it is actually the reality. If you have a typo, or if you, instead of sending 3 requests per second, you decide to send 3,000, the data model might be very different. So it's very important that you spend some time making sure that you send the right data over there. Now I'm going to show you what I did before. I told them to go and read the first second prompt second stage prompt or task, and then it went and read the task and completed the information. Then it's going to analyze what it first needs to create a file that is called the working log. The working logs allows LLM to have a scratch pad to write the files that it needs without having to create many files. We all have seen how LLMs like to create markdown files for intermediate steps. So the working log allows, we give LLM where it needs to write stuff. Now, it comes and reads the API access patterns, as we told them, also the MySQL logs. So it's doing everything that we have requested, also the table structure. And finally, it goes and generates the file that you're seeing. It all the time connects to Git. It is very important to do this step because if at some point you make a mistake, it is very useful to have a place to roll back, even locally. And I do that with Git. It has saved me a lot of time in the past. Now then we have completed task 1.1. It will go to task number 1.2 and continue with the analysis. So all of this is what I'm showing you here is making sure that we understand the source information from the source database. And then here is very important. So it told us, great, I have read all of the information from the different artifacts, but I still see that we have some missing data. I don't have the request per seconds. I don't have enough information. The load test that you have, or the MySQL logs, only have about 16% coverage, which is, something, right? So it's asking us to give all of the information from the different access patterns. Now, in the workshop, I have prepared, a script for you. By the way, in the workshop, we have kind of a step-by-step what you will be doing, what you will have to execute, ideas of the prompts, because remember, this is LLM based, so we cannot really predict what the LLM is going to tell you, but we can give you directions. So we have defined that in our sample application, we will be using 1400 queries per second. And in this prompt, I tell them the distribution. 20% is going to be authentication and user management, shopping cart 25%, and really product browsing and searching will be 60% of the traffic. So that's what I pasted here in all of this long chat. And based on that information, he was able to create the file that I just showed you before, access patterns with requests per second. So I'm going to scroll all the way down because at this point, it is asking me to make sure that if all of the information that I have right there, it is valid. It is a confirmation gate. I have many of these gates across the different places. So I'm going to say that everything is okay for now. Like, yes, everything looks good. Please proceed with the next step. And we will have to wait and see all the analysis the LLM will do and how it's going to continue working on the different tasks. At this point, we will call the MCP server, which is the task number 2. The DynamoDB MCP server will allow you to work with your DynamoDB data models. You will see that it will go and modify the different files that we have right there because we have it specified that it needs to mark the task as we go as completed. It's very important because if at some point you run out of context window and the LLM get lost for some reason, you can always come back to this. So recently I've been having a situation here with Git. So I'm going to do a quick hack, which is close and reopen, like restarting. And I can show you here at the bottom that it actually completed the Git scenario. Here it is waiting for the Git to complete. I'm just going to show him that he already did it, so he can continue. I cannot suggest you enough to use Git in any of these GenAI workflows at any step that you can. so you don't lose your work later. Here, we're asking us now, we're in the point that we have to call the DynamoDB data model. The DynamoDB MCP server, I'm going to approve. DynamoDB MCP server, it is a prompt. In simple terms, it is a prompt that the LLM will be using to create your DynamoDB data model. In the prompt, we have specified a lot of our knowledge, what we do as specialist solution architects in our daily conversation with customers. We try to structure the way or the conversation in a way that makes sense for the customer and the data model as well, and where we can use the base information that we have collected during the access pattern process or stage number one. I'm going to scroll all the way down. You can read all of this prompt. It is also available in GitHub in the official DynamoDB MCP server. And you can see how at the right, the LLM is generating a lot of these requirements, which is again another gate to make sure that you have provided all of the good information before we actually move further. Once you start generating data modelings, then it is a little bit more complicated to change stuff. So remember, always try to change things as early in the process as possible. Having said that, it is okay if you have to change things. It is, better in case you make a typo or a mistake. It is way better to just fix it than just let it go. You don't want to see how creative LLMs can get, especially not in data modelings. Now let's just give it a second before it finishes the file generation. Great. So let's see the requirements. The requirement file is telling us, I have identified that this is an e-commerce application, which, yes, we told them that. It will give us a list, and let me open this as a preview so you can see it more clearly. It will give us a list of all of the access patterns, and it will tell us the status, so if it analyzes it or not. We know that we have 48 different access patterns, so I expect this table to have 48 different access patterns here at the bottom. You can see that it goes really into detail, like in the request per second, if it is a read or write access pattern, what kind of elements you need, meaning user ID, card items, product inventory, like all of the attributes, and what kind of access pattern it is. So I'm going to scroll down. It says, great, I have 48 access patterns. Things are looking good. And also it tells us the entity relationships between, the entities, how they are related one with each other. And then it tells us some of the denormalization strategies. And all of this is before actually sending the requirements to the DynamoDB MCP server. So I'm going to go and check the DynamoDB MCP, the response on the data model. It is still working on the data model. It takes some time to generate this file. So I'm just going to wait a little bit, and I'm going to go back to the preview. Now, you will start to see the MCP server also suggests the LLM to have a scratch pad to document any concern that it might arise, like hot partitions, how many GSIs you will have to create. By the way, global secondary indexes, remember that they allow you to access the data with a different element that is not the partition key. And then if you have an opportunity for an sparse index, and all of the denormalization techniques that you might have here at the end. I think that it finished generating the DynamoDB data model. So I'm going to switch to that file to see what the DynamoDB MCP server generated. So let's see, DynamoDB data model, open preview. And this is where you have to spend most of your time. Because based on the data model, we will generate the migration contract.json. But if this data model doesn't look good, you need to chat with the solution and tell them what it needs to fix. So looking at it, we have the right request per second, which is really good. it is telling us that we will use co-location, which is really what I like to see. So we are starting to see SQL databases, they like to work with denormalized table. In DynamoDB, well, and other NoSQL databases, we like to work with denormalized structures as long as it makes sense, right? So if the data, it is related with each other, then it makes sense to put them together. If it doesn't, well, we just create a different table. So there is nothing wrong with that. So it's telling us we will use item collections. An item collection, it is an element in a DynamoDB table that shares the same partition key, but with different sort keys. So it's going to tell us we're going to put orders and car items. Using denormalization for performance, then separate tables. Of course, there are, it makes sense to have different tables for orders or maybe for products and users. And then it's telling us how it's going to get the aggregates. Aggregates in the terms of collection of items together. I'm going to scroll down to see the table design. So we are seeing it is telling us we will create a users table where we will have a user ID with 1, 2, 3. Okay. The sort key is going to be a word, in this case, profile. I don't dislike it. That will be something that I will do. We do have username in our data model. We will have email, and we have a bunch of metadata, which is just metadata. When you connect into the shopping cart, into the shop store, if you want to change your name, for example, or your preferences, you will go to this user table. That makes a lot of sense. That will be something that I will do. Very similarly, I might use a different partition key, not user ID. I prefer to use generic terms as PK and SK for my partition and sort keys because it makes my data model more flexible. But this is a really great starting point. So it's very close as I will do it. It is telling us here behind the scenes how many access patterns we support, the capacity, and the decision rationale for all of that. Then it is telling us we will create a GSI for users to find users by username. Makes a lot of sense because if you put a user ID here as the partition key, if you don't know this user ID, you won't be able to find users by email, for example, or by username. So right now, I can also think about an optimization. Instead of storing the information by a user ID, like a relational database will do, I could just put in my partition key either the username or the email. You have to choose. We can put the username, for example, or the email, and we will save one of the global secondary indexes. So even if the suggestion is good, it's going to give you the information that you require, we can remove it. So that's what we're going to chat later with the LLM. Now, it told us to create a product tables, which is our second table. A table just dedicated for products makes a lot of sense. There is no need to mix users and products. We don't have a requirement for it. And we are going to put only the product metadata. So very similar to what we had before. In the users table, we have the user in the sort K. Here we have product. We could use just the meta for metadata word or product as well. That will be something that I will do exactly like that. Oh, of course, I will change instead of product ID, a partition key PK instead of product ID and keep the SK. And then it's going to tell us to get products by category with a GSI, product by seller, which makes sense as well. And then we're going to the categories table. So that's pretty good. So far, it's been very close to what I will do. The categories table will tell us how much the different categories we have. It is still suggesting us a category ID. I don't really like it, have the IDs, because that's too relational. We don't need to have IDs. If we can just come and see the category name, we will save an index later, same as we have with the users. Because here we will have to get these categories by parent GSI. So yeah, we can work on this. this categories table, it is going into the right direction, but there's still some information missing. Then this is interesting. It suggests us to create an orders table. And it will tell us every time that we create an order, we will put it into this table. I will not go in this way. I will just do it differently. And then we also have a user card table. So now it is starting to get a little too much into the relational side. And let me show you what I mean by that. If I click into the data modeling, and I'm going to show you the relationship between the entities. We have categories, we have users. Every user will either sell or buy products, so they have the relationship with the products. Every user will put information into the cart items here at the bottom right. And when you have an order, only users can order something to the website, and those orders will have items. So the reality, when you order something, a user will have something in this table. So you are relating that with users. When you have an element into the shopping cart, if you remember what I did before, when I put things here in the shopping cart and I go to, let's just grab into any product, and I add it to the cart, I, as a user, selected my shopping cart and I have something in my shopping cart. So if I wouldn't exist, users are required to put things into the shopping cart. So there is a relationship between the users and the shopping cart and the orders. I think we can put all of those together in one table alone. We don't have to create different tables. This is what we will be doing right now. So I'm going to go back to the C line, and I'm going to scroll all the way down. And here I'm going to tell them that it actually did it. Before it continues, remember that I have to close and reopen, which is very interesting. I'm going to paste that he already did it, so it can resume the task. But what I will be doing, and in the workshop you have that. So when we have all of the explanation for the entities, which is exactly what I just told you, you can come to the users and imagine that we spend some time analyzing this data model, and we realize that instead of having a table for products, a table for users, a table for orders, and a table for shopping carts, I'm going to put everything in the same table, in the same users table, because remember, the data is related and the related data should stay together. So you come here, you can scroll all the way down because I already prepared the prompt that you can use. And I'm just going to show you how you can influence the MCP server, telling them what you need to be doing next. So here, this is, it is validating the data model. So I'm going to, for simplicity, I'm going to stop asking what it is doing, and I'm going to tell them my feedback right away. So if we can see how it is moving to the next stages. So I'm going to tell them with my feedback that we want to have one table where the partition key will be PK, is going to be the product ID. Well, I started with product ID, but actually, let's not do that. Let's just focus on the, oh, sorry, no, this is the users table. So let's go and give them the product. Let me just go to this one and see the product tables. Let's go and change the users here. Joe, will you have to edit this portion?
Oops, sorry, missed that.
Got it. And then let's give them the feedback on the products table. So remember that in the products table, we do want to make sure that that we use generic terms on the product on the partition key as PK and sort key as SK. And we provide a product ID without any prefix or suffix, so we can reuse the same ID that comes from the MySQL database. But also later, we're going to create a different set of GSIs. So that's what we're suggesting here on this specific data model. This is a conversation with the DynamoDB MCP server, and you will have to guide that conversation. It's not going to fix it. Well, maybe it will fix it right away, but usually it will take you a couple of iterations. So I'm going to show you how it fixes this one, so you can have an idea for all of the different, all of the other access patterns. For full disclosure, if you come to this workshop and you start working on it, it will take you 12 hours to complete end-to-end. And that's the optimized version. So I already reduced the time to 12 hours. The workshop that we created in Workshop Studio, where we started, it could be completed in about 2 hours. It really depends on you, how fast you can identify the problems in your data model and how fast you can continue. The key element in this workshop is to identify the right data model, because then after that, you generate the rest of the files that you will be working with. And also to use the DynamoDB MCP server to help you get with the data modeling portion. So in this quick demo that I had prepared for you was only focused on how you really get the source data you need to send to the DynamoDB MCP server and how you can analyze the result generated from the DynamoDB MCP server and the different data models. Do not assume that everything is right. Make sure that you double check and you read. So what I'm going to do right now, I'm going to check the artifacts in my DynamoDB data model. I'm going to expand this and open as a preview just to finalize, so we can have some time for questions later, and make sure that the changes that we created in the products access pattern was captured. Let me just scroll all the way down. Up, sorry. Then here it is. Actually, it is not. So let me see. Let me search for it. Okay, so I do see some changes. Let me show you. And that's what I was telling you. It might take some iterations. So it did took my suggestions to use a partition key PK and SK with the product ID, still put 1, 2, 3 with pre-appended by prod. Make sure that it doesn't have that, because if you keep that, the migration contract will think you will have to put prod underscore something. So we will need to tell the LLM, remove that. So it is just the number. And then it did put everything else that I asked. The category ID and the user ID, which, by the way, we also need to remove the user underscore number. And it did create the 2 indexes that I asked. Let me see if it kept the others. No. So this conversation is going into the right place. So it is understanding what I told them, but not exactly as I told them. So we need to keep iterating over this. I hope this video is helpful for you. It will give you an idea on how you can use the Workshop Studio so you can work on the different DynamoDB Modernizer application that you might have, but also you can work with the DynamoDB data model to enhance your application design. This was just stage number 2. Remember that we still have to go to stage number 6 and 7. In the workshop, I already pre-configured stage 3, 4, and 5. So we don't have to spend 12 hours on this process. I hope that this presentation has been useful for you. And thank you for listening. Remember, my name is Esteban Serna, Principal DynamoDB Specialist Solution Architect.
All right, Esteban, Let's go live Q&A. Just for Esteban, if you could turn your camera on, Esteban, let me know you're there. All right. There we go. All right. Let's go live. Let's do it. Just Esteban for now with the camera on. Everyone else, awesome. Let's do it. Hey, welcome to DynamoDB Day.
Yeah, thank you for having me.
Awesome. All right. So great session. Got a lot of questions. I know you'll be part of the expert panel as well. So if we don't get to all the questions, you'll have a chance to ask them after the panel. Get to the first question. How much does this cost? I mean, in general, how much do you pay for the AI prompts? Also, what would be your timeline estimate on migrating small projects like this? Let's say a few gigabytes of data, around 100 like MySQL tables. Can this also model some OLAP access patterns?
Mm-hmm. Yep, I see. So it really depends. And I know that this is not the most optimal answer that you want to hear, but it's because the most difficult part, it is to convince the humans about the migration. We can identify all the patterns. We can get all the information from MySQL logs and capture that into LLMs and send it to them. And maybe spend a week analyzing the output. But then you have to really be onboarded into what's going to happen. So from experienced people using this workshop and similar tools, it really takes a lot of time to convince the human on how much, on when to start the migration and how to go from there. So that's why what I say, it really depends. On the prompts, I don't have a rough number with the amount of tokens that we consume for executing the workshop. It might be, if I just get per token price, around $40 to $60 that it will consume to get all of those prompts. But if you think about it, if you are going through a modernization process, just the time that you spend doing that analysis, if you were have to pay a consultant or to hire someone to do that, it is going to be at least that per hour that they will have to pay. So what we're doing is making sure that by the using of these prompts, you simplify that process so you can maybe run several of these iterations.
Excellent. Next question, same. Yvonne wants to know. So you still need to be or have DynamoDB Specialist. The MCP only helps you to generate everything, but you still need to make sure it hasn't hallucinated anything and that the access parent table design actually makes sense, right?
100% truth. So what we have done so far with the DynamoDB MCP server, it is to give you a bootstrap. So if you provided some patterns and some directions, we are going to suggest a data model. Would it be the most optimized data model that you have ever seen? Maybe not. But that's where you have to start asking questions about it. Imagine if you didn't have the DynamoDB MCP server to get those data model answers, you will have to do it on your own. So you will have to create a data model. And usually data modeling takes a lot of time. So most of the customers think when you are designing a DynamoDB table, you get it right the first time. That's not really how it goes. You have iterations of data models, and you might have 4 or 5 different sessions on the same data model until you're happy with it. So it is an iterative process. And with the fact that we have now the MCP server, is we are enabling you to have a shortened feedback loop. You do have to read everything. You need to make sure that what you say is actually in there. But that really happens also in real life. I've been in many situations where we had the initial set of documentation for all of the data models. And then maybe in the second or third session, someone say, oh, by the way, that's not the most recent model. We need to start over. So it's really how it happens in real life. What we're doing is making sure that you get that feedback right away so you can analyze it.
Awesome. All right, so your session was a little bit longer, so we have a limited time for Q&A, but here's a few more quick ones. How much time should I spend on this workshop? What is the minimum you would recommend?
Yeah, I would recommend ideally 4 hours. You can do it in 2, but really rush into it. But I would at least recommend 4 hours. And anything higher than 4, it will be amazing.
Excellent, excellent. How can I run the DynamoDB MCP server?
You can access it right away. So today it is available in GitHub. You can just configure it. I maybe will put the instructions here in the chat in a bit. It is really easy to configure, and you can just play right away with it.
All right, probably last question. What phase or pillar is the most important?
The first one, data modeling. Because if you don't have your data modeling right, then all the rest, it is just a snowball effect. So spend as much time as you can on the data modeling piece.
All right, actually, this just slid in here. Are there any data privacy considerations that need to be addressed when using the MCP server during migration analysis?
So it is the same data privacy consideration that you will have when you choose which LLM to run this with. So as long as the LLM that you use is aligned with your data company policies, that should be sufficient. We don't get anything like from the DynamoDB side. We don't capture any data. It's really locally on your LLM communication.
Esteban, awesome workshop, really thorough. I know a lot of people probably want to have to watch the replay. Like I said, you're part of this expert roundtable coming up. So thank you for joining us, and we'll see you back here right after the roundtable. Thanks again.
Thank you for having me.
Thanks.